All right, hello. Oh, yay, it's on.
Yes.
Hi, everyone. How's everyone doing? You've made it after the party yesterday. Congratulations. I hope everyone's Unite is going really well. We want to thank Unite for inviting us to be out here this year. It's really awesome. So this is Brian Schwab. I'm Aleissia Laidacker. We're both from Magic Leap. Today, what we're going to be talking about is the who, what, how, why of spatial computing and Magic Leap 1. But what we're really going to be focusing the most on is really the how. What we're going to be doing today is a developer walkthrough to show you how to actually create a Unity project with the Magic Leap 1 platform and get to see what it would look like step by step on the device and in the Unity project. We're also going to be talking about best practices and discussing some of the tools that we're building internally for all of you as developers. So very briefly, who are we? My name's Aleissia Laidacker. I've been at Magic Leap for a little over a year now. Before that, I was at Ubisoft Montreal for about 11 years, where I was lead gameplay AI on multiple Assassin's Creed games. My focus was mostly on systemic AI design, building believable characters, and creating robust animation systems and procedural animation technologies.
Hi, I've been in the industry for a million years. My first game was actually on the Sega Genesis, believe it or not. I've worked at a number of different companies, including Sony, where I was there for the launch of the PlayStation 2 and the PlayStation 3, so I'm used to crazy hardware being slapped on my desk. And at Magic Leap, I've actually been at Magic Leap now for almost 4 years. I was like employee 65 or so, and now there's about 2,000 people there. And so I've been there for a while, and I've done a ton of research with my team, including Aleissia, called the Interaction Lab. And we try to do a lot of low-level exploration of the features, find good ways to use them, and find tools and tech that can like spur people to get better at using those features in the ecosystem. So, who the heck are we? Our mission statement is pretty big. And I think that it needed to be pretty big because like the thing that we're trying to do is pretty big, which is that we're trying to harmonize people and technology to create a better, more unified world. And we mean that in every sense of the word. We want people to be more unified, and we want people and their technology to be more unified. And what exactly does that mean? Oh, we'll talk about that in a second. I wanted to show you our quick little journey. This was 4 or 5 years ago. This was the device that was sitting on the end of the thing, and if you look, there's a little chin rest on the bottom of that just to show for scale. Like that's the thing that you actually put your chin on, that crossbar underneath the giant block. Like this thing was very, very large. It was a bunch of commercial grade lasers and a bunch of optics, and you could see the light field out in front of it. We very quickly tried to miniaturize it down. The reason it's so wide is because it's using the same block style optics that the big bench was using. Then we started to get into this level of prototype, and we actually kept this prototype for a very long time. This prototype was actually first built in early 2014, and we used it for the entire time so that we could speed up the iteration cycle on the actual equivalent device. Right? And so here you see I'm still using the prototype hardware in late 2016, but in early 2017 I already have the device on my head that represents a more typical, more finished form factor, and that's where we ended up.
So our form factor has changed quite a bit, and the question for us now is to show so what is it that we can actually build on this platform? What type of experiences and content can we build? So we always show this at our conference talks, and I know everyone in this room is really a VR, AR expert in here, but just to set the tone, VR really is when you put this headset on your head, and it's going to shut out the real world around you. VR, what I love about it is, to me, it's 100% about being immersed and escaping to a different world that the creators have built for you. AR is actually where you see this digital content that exists in your real world, but it's just there. The real world doesn't know about the digital content. The digital content doesn't know about the real world around it. When I play Pokemon Go, I can look through my phone and I see these little characters, but it's not like the characters have awareness about the environment around them. With spatial computing, with our camera and meshing technology, we're able to actually get full information about the world around you so that your digital content can actually interact with the real world. So the idea, though, of mixed reality, we've been hearing this so much in the last few years, but it's actually nothing that's really all that new. Many of us grew up seeing movies like Who Framed Roger Rabbit, or even the music videos from Paula Abdul when we were young, where this was really the first concepts of seeing digital content interacting with real-world people. Today, even Brian was telling me a couple weeks ago how his son is watching these cartoons on TV, and it's becoming really mainstream to see where digital content interacts with real-world elements. So, when building content on our platform, I think something that we're hearing really often is this a video game platform? Is Magic Leap 1 there just to create video games? And our answer is no. Actually, a lot of the content developers that we've been working with are working outside of that area of video games. Video game development concepts are something that all these developers need to learn, but the content that we're developing are across a very wide and very diverse spectrum of content. Meow Wolf, which is a large, huge location-based art installation where people actually can navigate through. We're working with them on the LBE scene. Singer Ross from seeing how can musicians and how does music translate to this platform, to sports, and as well gaming companies, but who like Phenomena, but who are really thinking outside of the box of the type of content that we can build for the platform.
So one thing that has been rough in getting people up to speed, some of these partners, is that there's not only a very large sort of tech leap to get people into an MR device, there's also a very huge design adjustment that needs to happen. There's a lot of things that you need to take into account that you probably haven't taken into account before. I want to talk about some of those. First off, less is more. You really don't want to replace the world. That is the key component of MR is that the real world is a primary actor in whatever experience that you're making. And by using less pixels, each pixel is much more magical. It's sort of like if I have a whole slew of things out in front of me, I'm more like watching a bunch of pixels. Whereas if I'm more watching the real world and something magical comes in front of me, it again, there's more real world cues, which makes that one pixel that much more magical. If everything is pixels, then nothing is pixels, right? And the other thing is that when you have a limited FOV in any way, if you put too many pixels into that FOV, you actually fill it up to the point of where suddenly you see the rectangle, and it looks like a television. And it puts the user's brain in what I call screen mode. And I'm not saying that this is a problem of limited FOVs. What I'm doing is I'm saying that when the users think they're watching a television, they tend to act in a particular way. When I sit in front of a television, I sit, and it's because TVs don't move, and it's because that's what I've been trained to do when I see a television. We actually ran a quick experiment, which is in VR even. If you're walking around in VR and you put a television in the middle of your VR scene, people will tend to stop and watch that television. And it's just we've been trained that TVs are a high output source of information and that they don't move and we should just sit there. And so by using too many pixels in a limited FOV, suddenly your brain goes into screen mode, and we've watched people have really awesome experiences and then suddenly stop moving, because an explosion went off and filled the FOV. And their brain went, oh, TV. And then it takes a while for them to get back out and start moving again. Respect the real world. Again, keeping people in the real world is the primary goal. And it's one of the hardest things to do because we're used to kind of grabbing a bunch of control and showing people what it is we want, as opposed to following around with them and being with them in the real world. It's not to replace, it's to extend. You are not in full control anymore. We've started to get used to this in VR where people are the camera, but now not only are people the camera, but this is the stage. The real world is the stage. And you're a guest in that person's world. Your experience is now the guest. They're not a guest in your world. And so your experience has to basically follow some rules. If I came over to your house and you telling you a story, and in the middle of it, your phone rings, and I just sort of get in between you and the phone and keep right on talking, I'm not a really good experience for you. I'm not a good guest in your home. Your experiences need to respect the real world and respect whose world it is. And finally, when you're trying to keep stuff in the real world, if you use a lot of real world cues, it will continue to trick the person's mind into thinking that the stuff is in the real world. So if you use physics, if you use object solidity, if I'm talking to somebody and they pause for a phone call and use social graces, if an object is bouncing on the table and I shrink it down and the sound effect changes because it's now a different size in the real world. All of these things are real world cues that will trick users into thinking that your pixels are in the real world because they're respecting the real world rules that every other object in the real world is respecting. Attention is a problem. I think a lot of people have, well, it's not a problem, it's something to consider, that people have started to deal with in MR or in VR, like how do you tell a linear story when the user can be looking wherever the hell they want? And we're finding more and more ways to do that. We've been doing a lot of studying, believe it or not, of like stage magicians and even stagecraft in general, because they have really good ways of sort of like getting your attention and drawing you over to where they need you to go, and then the person enters and then they drag you back. And it's all about giving people a little bit of a telegraph notion. The great thing about our device is that we have eye tracking, and so we know where you're looking. And if you're not looking where you need to looking, we can do stuff where you are looking, or we can get you to come over to where you need to be. We can use motion offsets in the periphery. We can use spatialized audio cues to take you where you need to be. And finally, you are, again, a guest in the real world. And one of the things that, if I'm sitting in front of a device like this, and I have an experience happening at me from a laptop or from a computer or from a large television, the user is pretty much focused on that. He's kind of your resource to consume for that experience. But in the real world, I need to do stuff out here. If the experience has me walking around or has me picking things up, I need to have enough cognitive bandwidth to actually do that task. And so you cannot budget the entire user's sense of everything for your experience. You can't throw too many inputs and too many things to take into account and too much information to tackle if you also want him to walk across the floor. Likewise, there's some safety considerations. If you are having them walk around on the floor, but the focus objects are all up here, guess what? They're going to trip on stuff potentially. Or if they have to back up, they're going to potentially do stuff. All of those real world sort of situations are stuff you have to take into account now. And also screen mode, when I'm looking at a television, I tend to focus out the rest of the world. I'm sure some of you have done this, where you walk into a room and somebody's watching TV, and you can practically go like this in front of the TV, and they barely even hear you. There's even a scientific condition called attentional deafness, which is that if you get too much visual stimuli thrown at you, you can actually somewhat go deaf. Your brain will literally turn off sound processing in order to fully encapsulate what it's getting visually, because we prioritize visual information to such a degree. So, I've just told you that you've lost a lot of control. You know, you had your old experiences on the screen with known inputs, and I've taken away your camera control. I've taken away your world, your ability to put markup data in the world, and your ability to like lay beautiful AI metadata all over the place. I've even taken away a bunch of your book learnings as far as like how to make stuff. And what have I left you with? You know, a big bucket of questions, right? And one of the things that we're going to do is tell you that a good device that has the right inputs gives you back a lot of your control simply by giving you user context that you've never had before. Head pose gives you a ton of information when you start mining it. You can get, you know, yeses and nos. You can tell if I'm walking and about how fast I'm walking. Hands have gestures as well as fully tracked hand poses, and eyes give me all kinds of data about where I'm looking, or even like some emotional data if I'm squinching up my eyes or if I'm surprised. And voice, I can do commands. I can register not only the sentiment by the volume and attenuation of my voice, but even just my breath sounds can give me some indication as to whether I'm excited or I'm holding my breath. And finally, we're actually aggregating some of this information over time, so we can tell you trends, both personally as well as like multiple users that are in an area. Like I can have an experience where things are going to happen in the part of the room where the vast majority of people feel joy. Crazy stuff like that. And so we have access to new streams of information that give you back experiential power through this better user context. And lastly, one of the things that my team is doing is trying to package up small MR examples and give out source code to give you access to some of the things that I'm talking about today. We're going to be putting this out with our dev launch we're calling it Magic Kit, and it's a series of small lessons with full source code and some assets so that you can have access to some of these interactions, as well as best practices for trying to get deeper into some of this stuff.
So where Brian talked a lot about more the user context side of things, what are the inputs, what do you as developers have access to in terms of what the user is doing, I want to talk a little bit more about the environment. So one of the things we stress to developers is there's also a lack of control in terms of knowing where is this content going to play. Everyone's living room is different. You don't know if someone's going to be playing the experience in their living room, in their kitchen, in their office, or in their bedroom. As game developers, we're used to one of the first steps we do is start mapping out what is the world we're going to be in. We start thinking about the whole level design process. And those two steps don't really exist anymore. This is where a lot of our background coming from designing systemic AI and thinking about how can ingredients work in different contexts, in different worlds, and in different experiences really comes to play with designing experiences for the real world. When thinking about the real world, though, you really want that content to interact with the environment. So you have to start thinking about how can actual physical objects display magical properties. You want your digital content to be aware that there is a table there. You want it to be aware that maybe there is a light switch, or maybe there's this old chest that exists in the corner of my room that I haven't opened for a very long time. But because I know that there's this box that exists there with my mixed reality experience, maybe it starts sending off these emitters. Maybe it starts glowing, and it really gets the attention of the user to go and interact with the real world elements. So what we're going to do today is walk through a Unity project that shows a bit about how do you actually use some of this user controls that we have on our platform, how do you take advantage of the environment, and how do you create a Unity project. So our simple example that we're going to do is basically this character that is going to interact with the space, be aware of some of the physical elements in the world, and actually sit down and interact with it. So first thing to do as a developer is you would head to our creator portal. On our creator portal, and this exists already today, you can download the Lumen SDK, you can download the Magic Leap custom Unity engine, and you can download the Magic Leap Unity package, which contains samples, prefabs, and a bunch of scripts for you to be able to use. So when I start up my Unity scene, I'm going to see that in my build settings, I now have this new option for the Lumen OS to be able to build for Magic Leap 1. When I start up a new project, of course this is optional, but users can actually go into the templates and select the Magic Leap template. What this does is it sets up a scene that has a camera where the camera has been set up for being able to do mixed reality experiences. One thing to note for when you are developing for any type of mixed reality experience is you no longer have skyboxes. You actually want to set the clear flags to solid color instead of the skybox and set the background to black. So once you have your camera set up, the first thing to do is set up your meshing in your scene. And here in Unity, now that I've imported my Magic Leap package, I could go into the Magic Leap folder under examples and prefabs and drag and drop the ML Spatial mapper prefab into my scene. If I look at what the ML Spatial Mapper has in terms of details, I see that the mesh type that I'm using is blocks. Now, what block mesh actually does is block mesh spatially subdivides the real world into a set of cubic blocks, axis aligned with the coordinate system origin of the current head tracking map. The mesh blocks are generated from the internal reconstruction model so that whatever geometry is inside these cubical regions in the reconstruction is represented as connected triangle meshes. Although mesh blocks are connected triangle meshes internally, the meshes between blocks are not connected. This enables easy and fast updating of regions of the mesh when changes occur in the environment. So what all of this actually means is if I have an experience where I've actually gone and moved a physical chair, through my depth sensor, I can see that there's been a change in the environment at that region. What this means with block meshes is I'm actually just updating the block meshes associated to that region, and I'm not actually updating the full mesh. What that gives us is real-time updates of the mesh into the system. So coming back to the ML Spatial Mapper, I see that there is a mesh prefab that is already associated to it. In this original prefab, I see that the material has been set to wireframe, which is using Unity's built-in shader for spatial mapping that exists for occlusion. In this example, though, I'm going to create my new mesh prefab just so that we know what it takes to be able to set up your own shader. So in my mesh chunk example, 3 things that I have to take note of. 1, I want to make sure that I set a mesh filter object. I want to be able to make sure that I have the mesh render that's set and the mesh collider. The mesh filter is going to be auto-generated from the ML Spatial Mapper with the information as the meshing is happening in real time. In my object, I've set a new script, and in this script for mesh chunks, what I'm doing is I'm just creating my own shader so that when we see this through device, instead of having wireframes, I can actually have something that looks a little bit more beautiful. Last bit to note, and this exists on the original game object as well, I've set the layer here to environment mesh, which is a custom user layer that I've set that I'm going to explain why I've set this in a moment. So basically, at this point in your scene, all you have is your camera. You may have drag and dropped the ML Spatial Mapper, or maybe you created your own like we did. And with those 2 elements, you should be ready to test on device. So in this example, this is some capture that I've taken so I could actually see that with these 2 game objects and I push it onto the Magic Leap 1, I can see the meshing happening in real time, and these blue dots are my custom shader that we've created. So at that point, now that I see meshing is set up, I want to set up my nav mesh so that my character can actually walk and navigate on the mesh. So here I'm going to go to Unity's GitHub and download the nav mesh surface components that exist. Hopefully one day this is built in by default to Unity. And once I go back to my Unity project, I create my nav mesh surface gameplay object. I set the nav mesh surface component on here. And this is where I would take note of the include layers. This is where I've set the environment mesh layer that I've associated to my meshing mesh chunk component. This means that everything that's scanned in through the meshing system is going to be used for the nav mesh surface. In this example, because I've actually got a humanoid, I'm going to set my agent type to humanoid. And there's a few interesting things to note. By default in Unity, which is totally normal, a lot of these settings are set up for creating traditional video games. But now we have to start thinking about, well, what are some of the metrics that are going to have to be changed for it to work in real life? So one thing, the step height by default is normally at 0.5, but this is really much too high, and if I kept it at that value, I would have my characters starting to step on the couch, starting to step on my tables and my chairs. So I set this lower to make sure that that is considered excluded from the mesh and the character doesn't walk on it by default. The max slope I've reduced as well. By default, I think it's at 45 degrees. Now that we're dealing with meshes that are being generated for the real world around you, meshes are going to be a lot more noisy. Basically, we're not getting meshes that are completely perfectly generated and where the map has been done by a level designer. So I make this much lower so that if I've got shoes or if I have a box or I've got my bags that are on the ground, I'm not going to have the character that actually steps on top of these objects. The nav mesh is going to avoid these small cluttered objects on the ground. So that's one thing to keep in mind is really like what are the real world measurements? And in my case, I've set those parameters based off of a humanoid, which is of real scale and of real size. But if I had a small little character, maybe it's a small dinosaur that is, say, like 1 foot tall, then those metrics are going to change. So you really have to start thinking about how do you want your characters to interact with the real world objects around them. So at this point, I'm going to test my nav mesh in editor. What I've done is I've set a couple of just gameplay objects. I make sure that I set them with that layer of the environment layer in the tags so that the nav mesh avoids those specific objects. So once I see that the nav mesh works in the editor, now I want to test on device. But right now, I actually haven't called anything to say generate nav mesh. So for my test, what I'm going to do is use the Magic Leap inputs from my control to do this. So here I'm going to create a new script called user controls, where I make sure that I've imported the Magic Leap class to get access to all of our APIs. From here, what I'm going to do is make sure that I've got a function to my Magic Leap input controller, because that's what I want to use, where I press the bumper, and the bumper is going to bake my nav mesh. In this start, I want to make sure that I have a reference to this controller so that I could use it later on. And I'm going to set up a callback so that whenever the on button down is pressed, I could actually see which button is called and then update my nav mesh. In that callback function, that's exactly what I'm doing. I'm checking to see if the button that is being passed in is the Magic Leap input controller bumper, and I'm going to update the nav mesh at that point. So something that developers ask is, how often should I be scanning? How often should I be baking? How often should I be updating my nav mesh? And something that we always tell developers is it really depends on the experience that you are designing. Let's say you are designing for a small scale room experience. You know it's going to be maybe just for someone's living room. Developers tend to have this scan and bake phase where you actually explain to the developer meshing is running right now. We can use our confidence APIs to see how much of the walls and the environment have been scanned. And the developer at a certain point goes, this is good enough. Great. I'm going to turn meshing off, bake my nav mesh, and I'm not going to worry about anything. Developers also at some point might want to force an update on bake nav mesh or rescan if it fits in their experience. Maybe there's part of your experience where the character tells you, hey, do you mind moving this chair for me, or would you mind going to bring something into the room? So that when you as a developer know that this has happened, you can call the system to be able to rescan and update your nav mesh. But then there's some experiences where you just want this to be updating continuously. Let's say you're in a large-scale location-based experience that is a huge, huge room with lots of people and lots of moving objects. This is something where the developer might set it so that periodically you are doing these rescans. Again, just like in any video game that you've developed, if you're continuously rebaking your nav mesh, this has performance hits, so you want to make sure that you're designing this based off of the type of experience that you're building. So now that we've got the nav mesh set up, I want the character actually to do something. I want the character to walk around. So what I'm going to do, again, is use my control. My control is full 6th off, which means that I've got my position of the control, I've got the orientation, and I could just do a ray cast forward to see what is the actual point in the mesh where that hits, and then tell the character, move over here. So in this example, here we see this is where the character now is using the nav mesh. I'm actually using the control to say, come over here, walk from this space. And the character is actually avoiding and respecting the real-world geometry and only sticking to the ground mesh that has been generated. So just having a character move around a space, fine, that's great. But as me and Brian were saying, where we want to see developers move towards is actually having their digital content interact with the real-world elements. So Brian talked about MagicKit, and one of the things that we're building for MagicKit is a plugin called the Environment Toolkit. With the Environment Toolkit, we're building affordances about the environment so developers can actually know where are there seating locations, where are there hiding spots that exist in my room, where are the corners. We're also doing terrain analysis so that developers can actually know where their content can be placed, where are the areas that the user can actually navigate, where are there actual planes where it's not being blocked by clutter on the walls. So here we're going to use the hiding spots so that the character can actually navigate with the real world and sit on the couch. So that's one thing, like we really want to make sure that affordances are something that people are stressing to use. Having this environmental information is really key to making it so that your digital content looks smart and so that your digital content is really aware of the space that they're in and utilizes that. So for the last bit of the walkthrough, we're going to show a little bit about how we use our gesture system. So one, we've got these 8 built-in hand poses that we see. No hand, fist, pinch, thumb, the L, open hand, OK, and C. And in your code, what you're going to want to do is actually enable the gestures with the specific poses that you're looking for. The reason we do this is because we have our depth camera sensor, and by default, it's in our far range so that we can actually do meshing and updates and scanning of the environment. When we want to enable gestures, what that does is it puts the camera into the close range. Also, because we've got these 8 built-in poses, you actually want to specify which one makes sense for your experience so that you are only processing and trying to find hands that match those specific poses that you're using. So in our example, we've just enabled the open hand, and what I'm doing is I'm checking to see if the current static gesture that's been enabled is the open hand of either the right hand or the left hand. At that point, when I detect that, when I wave at my character will wave back at me. So in this example, while I'm walking around as well, I'm actually using my head pose information so that the look at system that we've set up on this character is constantly looking at my head pose. And then in here I do a little wave, and she waves back. So in this example, all I used was the ML hand, but we also have gesture APIs to be able to get access to specific fingers, to key points, to thumbs, wrist, and different information on the different key points on the fingers. So developers don't need to just use our built-in systems. They can actually use those points and develop something that's custom for their experiences. So just a small note about some of the other SDK APIs that exist. In this example, I use the head pose for the look at. I use the world raycast meshing and planes for the environment toolkit. And something, as Brian had mentioned, eye tracking and also our image tracking APIs are something that we see developers using a lot of. For eye tracking, something that we're always stressing with developers is, let's say that character was sitting on the couch and I've ignored her for a couple minutes and my eyes are always darting towards something else. We could track that so that the character actually talks back to me and goes, what, am I not interesting enough? Maybe you should look over here while I'm talking to you. And then in terms of some of the tools that we have, our spatialized audio engine is really powerful. I think one of my favorite experiences I've seen is actually the stealth experience, where it was very minimal in terms of the visuals, but just having it where I was trying to hide from this character and hearing the different spatialized audio moving around the room, it felt really eerie. It was almost like this Jurassic Park moment where you're like, all right, I don't hear it anymore. I think it's safe to come out. The video capture, this is something that exists for being able to do Magic Leap captures on device. This is what we use today to be able to do the captures. So something really interesting for developers to be able to record all of your own content and share it. And yeah, for the next bit, this was our simple example, and then Brian's going to dive in a little bit more into some more complex transmodal interactions.
So a lot of what Aleissia was just talking about was sort of like greater context in the environment and being able to take advantage of that. But this is a wearable computer. You actually have it on your own head. And so we're able to get a ton of context from the user specifically. And one of the things that we've found in our research in using this is that the head, eyes, and the hand form a critically interlinked sort of tuple of inputs, the vestibular, ocular, manual tuple, if you want to call it that, or head, eyes, hands, right? And the reason that they're critically interlinked is because these are the things that for many, many tasks, humans use these in a very coordinated manner. If I'm going to reach out and grab something, I tend to look at it. I tend to focus on it with my eyes in roughly similar sort of muscular movement ways that I do with my head, with my eyes, and with my hand. And so what we mean by a transmodal system is one that uses this critically interlinked tuple, analyzes both the pose and the motion of these three input streams, watches for specific patterns and correlate alignment within those input streams, which then indicates biological, biophysical context. It allows me to know as a human being I'm in the middle of a particular action. And then we can combine those inputs together, knowing that context ahead of time. And in fact, knowing that context, we can largely also infer the target object or the focus area. Combining inputs is sort of an interesting blasé word. We've actually found a fairly large spectrum of combining inputs. You can either be a modal, which is just a single input, not combining. You can have multimodal, which is multiple inputs being parallelly used. So if this input is above this level and this input is also above a level, you can then start to actually blend them, which we call cross-modal. And then finally, what we call transmodal is by knowing greater and greater context of what the user is doing at any given time, you can basically reblend those inputs as you need for the particular context and the particular actions that you're doing. So what do I mean when I say we analyze the input poses? Well, I'm just talking about the spatial analysis, right? So like the particular configuration of the hand or the particular configuration of the eyes. Are they blinking? Are you doing a particular thing with your head? Just the particular moment-to-moment spatial analysis of the device, of the inputs. And then finally having a pose manager, which if you've ever done any sort of advanced animation systems, basically just lets me store these individual spatial poses of the particular input, as well as the transitions between them, the correlation of the basic feature points between these transitions. So if I have a pose like this with 8 feature points on it, and I go to a pose like this with 8 feature points on it, I can correlate the 8 points on this pose between the 8 points on that pose, and while I'm in the middle, I can infer where those 8 points are as I transition. So I can get a beautiful set of feature points that are being tracked on the hand that exist between recognized poses. And in fact, I can also do persistence rules for if those points, say, move out of the FOV, the actual field of sensing of the device. I can keep persistence rules to stop at the edge of the field of sensing and like alert the user that they need to get their hand back, or I can like let them drift using whatever velocity they currently were using. Those sorts of rules. And then we analyze the actual motion of these different inputs as well, right? And that is actually a full temporal and spatial analysis of each one of these inputs. So now you can actually get swipes or strokes or pinches or even two-hand actions where you're actually You're noting the pose of the actual hand, let's say, but you're also noting its movement in time, and you can call that sort of a macro gesture or something like that. With head, you can get nods and you can get shakes and you can get gross body movements, like am I laying down or sitting up or walking or crawling. You can get those sort of notions based on this level of analysis of the head. And at the eye level, eyes are interesting. Eyes move very, very fast, and so the vast majority of actions for a particular eye just involve about how long is it stopping on something, because eyes don't typically stop. They kind of keep going. And so when they do stop, that's when you can tell that the eye is trying to do something. If you stop for a short period of time, it's called a fixation. A slightly larger period of time is called a dwell. And then you have actual eye behaviors, right? I rolled my eyes. Or there's an old one where if I ask you a question, if your eyes go up to the left, you're probably trying to remember. And if your eyes go up to the right, you're probably trying to think up an excuse. You're trying to invent something. And like I said, common amongst all of these streams are the types of motions that we do when we're following objects or when we're landing on an object, smooth and ballistic pursuit. So if there's an object down there and I go to point at it, let's say, my head is going to do a ballistic pursuit on that static object, my eyes are going to do a ballistic pursuit on that static object, and my hand is probably going to do a ballistic pursuit on that static object. That allows me to correlate these things. And then the other thing that all of these inputs do all the time is nonverbal communication movement. Like if you can detect that the user is talking, you should probably ignore what he's doing with his hands, especially if these particular gestures are hooked up to your experience at all. Because otherwise, various people that talk with their hands a lot are going to have a real hard time enjoying your experience. So now that we have pose and motion information, we, again, like I said, look for key correlation between all of these streams and figure out what the action is. That gives me the intent. So in a particular case, the user might be targeting. At that point, I also can start to allude to what the focus is. And the more inputs that I get and I start to analyze, the more I can disambiguate what the focus is more directly. And at that point, I can also start talking about range. Is it in the near field, the mid field, the far field? The reason we split this up is because we're trying to, in the end, we're going to generate a fairly intelligent contextual, let's say, targeting vector for the user. If you're in the near field, you probably want it to go from the pinky. By near field, I mean within a meter, within my working space. You probably want it to go from the end of your finger from here, like you're pointing, like this. Whereas if it's out there and I'm like this, the vector is probably from the tip of my finger from my shoulder, because that's actually how I tend to aim when I am pointing in the far field. To this, we have built what we call a full-blown interaction model for transmodal interactions, and we're calling it TAMD because we have a lot of NASA people, and NASA people love acronyms. And so all that really stands for is just targeting, activation, which is actually selecting one of the objects that you've targeted, manipulation, which is either directly moving or changing that object that you've selected in some way, disengaging with that object, and then reintegrating it back into the real world. And reintegration is actually interesting. Like, we don't tend to have to do that much in Windows or in a typical game, because the objects tend to be either fixed in the UI is sort of fixed up in the corner of the screen or whatever it is. And so you just push the button. You don't have to do anything with it. But if I have a digital object that I have picked up and I let go of it, reintegrating it in the world literally might be to drop it to the floor, if that makes sense, if you're following physics. Or it might be that by picking it up, I've given it wings and it now flies right there and it sits there, and then that makes sense. Reintegration back into the world becomes one of the ways in which you respect the world, though, and so this becomes a fairly important step. And this is a cyclical thing, right? Like as you get done targeting, you start to go around the wheel and you do the whole 9 yards. Obviously, any of these can be skipped. I can target things and just anything that I'm targeting is immediately activated, and I start blasting it with force powers, right? And so I've skipped activation and manipulation and deactivation. I'm just immediately targeting and reintegrating the force-pressed objects back into the world. The reason I've pulled out targeting here is because I want to actually step through it completely, just as a recap. And so in a full TAMD targeting, the system would recognize that I'm actually doing a particular pointing pose. But it also recognizes that my hand, my head, and my eyes are heading in a targeting action towards a particular focus. I determine that likely focus and the range to it, and then based on the fact that I am targeting and I have found some focus, I can then return a qualified target vector using an intelligent set of blended weights that are smoothed based on which range of motion, which range of targeting we're talking about, and we know the vector origins again based on the fact that we know the range to the probable target. All of this stuff is being bundled up kind of for you and kind of delivered as a smart, intelligent input model that you can use to more easily leverage these sort of key correlated inputs. And so finally, these three form a very critically interlinked set of inputs for human interactions. They allow you to get physiological context. And that's the beautiful thing, because like when I just hand something to somebody, they tend to do the exact behavior that we're trying to recognize just naturally. They tend to correlate their eyes, their head, and their hands, whether they're reaching out to grab it, whether they're pointing at it, or whether they're just trying to get rid of it. All of these types of behaviors can be recognized as human behaviors that we can use as context to properly target and blend all of these inputs together in a good way. And it helps to make these more accessible, because these are naturalistic inputs. These are the way that people want to interact with things. So we are bundling up a lot of this transmodal targeting, including initial documentation and example code, and that will also be shipping with MagicKit, with a lot more to come, including the entire rest of the TAMD circle, and also a lot more debugging inputs and a lot more built-in pose manager systems, so that again it's easier to sort of wrap up.
So a few final notes. One, we want to talk about challenges when building mixed reality experiences. One, as we talked about, there are so many more inputs now that characters actually have to process. From, am I looking at the character? Am I using my control? Am I getting up? And am I walking towards it? There's a lot more inputs for AI systems to have to start thinking about handling. Something that we've said before is we think that we're going to start seeing developers start to flock more towards using AI planners versus traditional behavior trees, so that characters actually do have some form of agency themselves. And with that environmental awareness and all of these inputs, they're actually continuously changing and adapting the way they should be behaving. One thing that we've been talking about is we've said that we think the new uncanny valley is going to happen in mixed reality, where characters don't actually react to the inputs around them. So if I'm interacting with a character and all of a sudden my dog rushes by, if that character doesn't react to my dog, the experience is going to feel really broken. Or if I'm there having a conversation and all of a sudden someone in the room next to me breaks a glass, if I don't actually react to this loud sound input, again, it's going to feel broken. So developers, especially AI developers, have to start thinking a lot more about how to build rich reaction systems, how to use AI planners to be able to have characters that do adapt to the environment that is continuously changing around them. Animations. Animations is also a huge challenge, and it was good this week at Unite. We've been hearing a lot more about motion matching and procedural animation. In video games, I know for years it was where we would build these games and level designers would need to know the metrics. Animators would have to know the metrics so that they would make sure that they had a jump that supported that 3-meter jump. That was it, a bit of blending, and we're good to go. But now we don't know if a character gets to the edge of my table and needs to jump down. We don't know how high people's tables are going to be. It's going to be really difficult for animators to start thinking about building animation systems that support worlds where metrics is no longer a thing. So something that we've been telling developers that we want to see them doing is actually designing their reaction systems based off of the fail states of the animation system. If you pull your animation system and it says, I need to jump down, and it says, well, I don't have an animation, we want to actually see it where the characters go, this is a little bit high. Do you mind moving a chair over for me so that I can actually jump down? using those animation fail states will also allow it so that you can design experiences so that the user gets involved. The user has to move a chair for the character to walk by. The user has to move maybe a cup that's blocking the character from doing something on the table. Final bit, storytelling opportunities. Reason we talk about this is I think a lot of the mixed reality experiences or AR experiences that we've seen use tabletop for telling their stories, and we've seen portals. The issue we have with this is that when I think about a table is actually where I put my laptop down. A table is where I sit down, and essentially that's where I'm watching my screens. Portals are the same thing, where sure, if I see a portal that opens up on the walls, it's going to encourage me to get up and walk over to the portal, but I'm still essentially looking at a screen. Where we want to see developers go in terms of storytelling is really these character interactions and interacting with characters that are fully aware of their environment. With a lot of our early access partners, we've seen that the content that's being developed, because they're really thinking about what can I do inside someone's home, we're seeing things where they're developing these character interactions where it's all about bonding, about trust, about protecting, or about teaching and learning. And to us, coming from like traditional, especially AAA, this was really nice because it's really nice gameplay verbs. It's not dystopic. Like, we're not seeing people wanting to do all this like crazy violent stuff, because these are things that people are going to be experiencing in their homes. So we really want to see developers that are focusing on these beautiful interaction moments that focus on stories. And it doesn't matter if you are building a game, a location-based experience, an application, or even something for enterprise. People remember stories. They don't remember data.
So why are we here at Magic Leap? Why are we putting up with this crazy company and living in Florida? Well, some of us.
I live in California.
And I think that for me, the biggest reason, the reason why I tell people that I do this is because I've spent years now exploring mixed reality, and every single vertical that I've ever gone in, every direction, every time I stick my shovel in the dirt, I find gold. Like I have not dug for very far and not found something that feels better, qualitatively feels better than the way that I currently use a computer. And that is just fascinating to me. Like I sometimes joke that I already have a wearable computer. It just has a really shitty FOV, and I have to hold it in my hand. And I do a lot of things like it is a wearable computer, like I have pixels where I need them in the world. I already have a lot of wearable computer tasks, and I rely on my phone to take care of them. But it is a bad wearable computer. And like, for me, the reason I'm at Magic Leap is because I want to enable all of these verticals with better use of compute, better, more contextual and more rich use of pixels where I need them in whatever I'm doing. I see this revolutionizing education. I see this being able to teach much more complicated user interfaces because I can get that help in real time, contextual, right where I need it, and I can lessen the gap between stimulus and response, which is exactly how human beings learn. And so like that alone is just fascinating to me. Like, we have these crazy abstract interfaces on everything now because we can't learn them very fast. When we don't have that problem anymore, imagine how much cooler and more contextual and personal our interfaces can become. We've also got a ton of work in the health and accessibility fields because we do have these personalized inputs that are held in a way that's a lot more natural than something in my hand, so that if maybe I don't have a hand, I can still interact with this device in a very rich way. If I'm bedridden, I can still do some things. So all of these sorts of things, and just being able to visualize health information in a much more natural way as well is going to help doctors to be able to talk to their clients about very difficult problems and very intricate situations without having to kind of like resort to hand-wavy information or just not tell them. They can show them. Hold up your arm. See that thing? It's blocking your blood flow. That kind of thing. So we want you to come with us because the journey starts here. Like we have found so much goodness, and we want to share it with you guys. And we want everybody to eventually get into MR because we think that it is the way that we will be using our compute in the future. So thank you.
think we have
We have 6 minutes.
5 minutes for for questions.
5 minutes if anybody wants to ask a couple questions.
Hi.
Hi, thanks a lot for making an appearance here tonight.
Thanks.
Which is kind of, there's a major topic here, seems to be connected games. Can you share something about the possibilities of sharing a Magic Leap experience between users in the same area or with the internet, cloud and stuff?
Yeah, no, that's been a huge, in fact, like usually when partners come in, I tell them that that's one of the most magical things because for two reasons. Not only most people haven't done a lot of sharing of pixels directly, like that is a fairly novel thing, and it feels very magical even in a lame version. If I open a Google Doc and we both type into it, it's actually somewhat fun. Like just that's the lamest version of sharing pixels, right? And so we have found over and over again that it's super compelling, much more than single user stuff. The other thing is that if I see something crazy magical run across my floor, I'm going to doubt myself real quick. And being able to like look at the next person and go, did you see that? And have them say yes. We actually look to other people to back up what we see to make sure that we're not crazy. And so it tends to, again, be a real world cue that helps things be grounded in the real world. So we're doing a ton of research. We've not only done research on multiple devices being in the same area, but multiple devices being in different areas, as well as our device with somebody on a phone, our device with somebody in VR, our device with somebody on a laptop. We've done cross-platform as well as inter-device sort
You
of
can do it in
situation.
Unity, so it's supported on the platform.
Yeah.
Yep.
Cool, thanks.
Thank you.
Hi. Thanks again for a great talk.
Hi.
I was just wondering, how flexible at this point is your hand pose recognition? For example, if I don't have a typical hand, I'm missing a finger. How do you accommodate that?
So our machine learning team is actually doing a ton, and one of the things that we learned real early on, because some of the early stuff that we had worked on like years ago did suffer from that. And we actually have a diverse enough group of humans at Magic Leap that like there was a lot of people with different skin colors or with like large amounts of jewelry or hand tattoos or what have you.
When I first joined, it was like, all right, guys, you got to do some work. Like, yeah.
And so we learned very early on that like we had to accommodate for a lot of that. And so we actually have very, very little problems with that because we use a lot of not only captured data amongst the real humans that we have access to early, but we also do a lot of synthetic data on our machine learning. And we can simulate a finger being off very easily on synthetic data, right?
And we have a very diverse set of user testing. So, yes.
Ah, great to hear. Thank you.
Yeah. Thank you.
Hi guys, I have two questions and I'm confused about something a bit because you talked about that you wanted to get the user out of this screen mode as you described and to give the user a more active role than a passive role. But in one of the earlier slides you had the logo of the NBA as a partner or a cooperator. And I had watched former NBA basketball player Shaquille O'Neal's video on your website, I think, or on YouTube, where he tried the Magic Leap and where he described his experience with Magic Leap. That he said that he watched the basketball game right in front, on top of his table. So my questions are, do you see Magic Leap as a platform for sports viewership in the future? And doesn't that kind of contradict what you just said about screen mode and the passive and active role of the user? And he like literally says that LeBron James was on my table. So can you describe that demo? Was it like a CGI? Was it like a reconstruction of a game? Or was it just like live filmed? I was wondering about that.
So what I guess I should have added to that slide was like, unless your experience is that you want a screen, right? If you want to just put a movie on the wall, that's fine. We can do that. Mm-hmm. And in fact, that particular experience that Shaq saw was live footage of actual NBA, as well as 3D augmented play-by-plays and some other extra information that was playing out on the table in front of him. And so he had the ability to like ask for additional information and interact with some 3D assets at the same time that he was just watching flat TV stuff up on the wall. And so in that particular experience, part of that experience is to watch a television. Mm-hmm. So like I agree with you, that was a little confusing, but like what I more meant was in the general sense, like obviously we can show a screen, and we want to be able to do that because there's 100 years of screen-based entertainment out there that we would love to be able to still consume. But MR in general is better suited when you're making maximal usage of the medium.
Okay.
And even on the APIs, like we showed that there's the planes API. We didn't use it in that example, but that's so that if users are really just like, I just want to place something on the wall and that's my experience, that exists. But so much of our work has really been done on this world scanning with meshing to be able to get access to everything, doing the room solving, giving information to the developers. To us, that's where we want to see developers go.
Okay. Thanks so much.
But thank you.
Thank you.
I think last one.
Last one.
Quick one.
Hi.
You showed both the controller and then the hand gestures later on. I'm wondering, is the controller here to stay, or how the two are working together?
So here's the thing. I am of the opinion through many experiments that even if I had perfect hand tracking, perfect 200 hertz hand tracking, and I have a floating thing in front of me and I go like this, it is less compelling than if I have a controller that gives me haptic feedback directly when I hit the button. We use our hands as a callback function when we hit things physically. In fact, if you are going to have a button, I would rather have you stick it next to something physical so that I just push through it and touch the object anyway, so that I can use that callback function. But one of the reasons that the controller is here to stay is because it gives you a chunk of haptic feedback directly in those nerves. It also is a much higher fidelity track for now. It works outside of the field of sensing, so I can put it in my pocket and I can do stuff. I can use it over here. I can be sitting at a table and be typing into my controller down here because it doesn't require line of sight with the senses. And also, there's other physical feedback systems like a trigger analog controller that people are used to using. We can use the types of muscle memory that we have on that. Now that being said, we are working very hard to get as good of hand tracking as we can because that is a naturalistic input and we want this to be as accessible as possible. And we want people to be able to still do as much as they want to do. But for certain applications, the controller is still quite a bit better.
Yeah, so you don't need to have it. It really is up to the developer. From my personal opinion, and I know you and me, this is where we're like yin and yang a lot of the time, but I want just like the natural inputs. I want it so that like I can create an experience and have my mother and grandmother who have never played any of my Assassin's Creed games because they don't understand the game controller to actually get to experience it because it's been designed around natural inputs. Where am I looking? What am I touching? Am I like crouching or standing? But again, it's there so that developers can choose what they want to use for their inputs.
For sure. If you're doing a CAD application and you just need greater accuracy, you should probably use a control for it.
Yeah, that's how it feels more and more from what you're saying. In a way, the hands become very much the kind of contextual character gesture, human interaction, while the controller becomes more of a, let's say, UI kind of side of things in a rough way.
It's good at certain tasks and gestures are good at other tasks. We've actually found that there's actually a good mix of like doing gestures with one hand and using the analog controller in the other hand, and that mix feels very good. You know, it's almost like you have a digital hand and a real hand, and you can kind of get interfaces that take advantage of that modality.
Cool, thank you. Thanks.
All right, thank you very much, everyone. Feel free if you want to come ask us questions after.